Okay, in theory, we should be live. Hey, everybody! Welcome
Nice.
to Open Space Monday here on my YouTube channel. Once again, this is just a live, totally free-form chat. Sometimes with a guest, sometimes without a guest. This week, I do have a guest, which is my good friend Moiya McTier, who is one of our co-hosts on the Weekly Space Hangout, but has got about 8,000 interesting things going on. And so as I started to sort of, unpack them one after the other, I realized, man, she just come on to the open space and we can just chat about them all. So for people who don't know who you are, or maybe haven't heard the intro a bunch of times, who are you? What do you do?
Well, my name's Moiya McTier. I'm really excited to be here. I'm an astrophysicist and a folklorist, usually based in New York City, but right now I'm up in Maine to escape the epicenter of coronavirus. I study planets outside of our solar system and how they're affected by the motion of the Milky Way galaxy. And I do a lot of science communication on the side because it's my passion. It's what makes me happy.
So I just need to warn people just in advance that you are in like a small cabin in Maine somewhere, totally off the beaten track. You're relying on satellite internet, and we are clearly in the pre-Starlink era of satellite internet right now. Um, so
Absolutely.
yeah, so one thing is like your bandwidth has been reduced, and so at some point, the bandwidth may improve, and then suddenly you're just going to grow gigantic on the screen, and so I will have to sort of reset that. And also, we're going to hear a few like electronic robot voices, but I think the audio overall sounds pretty good. So I think we're, sort of like right on the edge, but I think we'll run with it. So let's talk about your scientific work first, and that is you are at Columbia, right? You work with those
Yeah.
exoplanet people that we keep
The,
hanging out with.
those exoplanet people. Yeah, I'm at Columbia in David Kipping's Cool Worlds lab. He's been my advisor all throughout grad school.
And like, what have you been specifically focusing on?
Yeah, so I've bounced around a little bit between exoplanets and galaxies and then decided to combine them for my dissertation work. My first ever project was trying to find a way to determine how mountainous exoplanets should be, which is really difficult to do because if you took Earth and you shrunk it down to the size of a pool ball, a billiard ball, it would be smoother than a real like regulation billiard ball, even with all of the mountains that we have here on the planet. So finding mountains on exoplanets is really hard. And that was my first project. My second project was looking at how groups of stars move together around the Milky Way, and then I combined them for my thesis work, which is what I do now. And now I'm looking at how stars in the center of the galaxy, how their motion will influence the types of planets that can form there.
So let's talk about let's talk about those separately first. This idea of seeing mountains, and so was that surprising to you that actually I guess the contours of the mountains as you're observing these planets would be so tiny compared to the planet? Like, did you rule that out as a good way um, to observe any features on an exoplanet?
Pretty much, yeah. It was my first year project, so I was brand new to grad school, and I didn't have any ideas of my own. So David threw this at me. He was like, "Try this out," and I was like, "David, this totally isn't going to work. We're not going to be able to do this." But he was like, "Trust me, try it." And then I did all the work to figure out how it would affect the signal. So what we decided was, if you're looking at a planet transit in front of its star, there's a part of the transit at the bottom where theoretically, in an ideal case, that bottom of the transit would be perfectly flat. But if the planet has mountains and if the planet is rotating, then the shape, the planet's silhouette is changing, and that would create these tiny little jagged bumps at the bottom of the light curve. And if you have a powerful enough telescope that can measure those bumps and then kind of reverse engineer to figure out how bumpy the planet is.
And like right now, when astronomers are observing exoplanets, they're like maybe teasing out the atmosphere of the planet as a separate part of the signal. Um, So how much better of a telescope do you think that we would need to be able to see that?
A much better telescope than we have now. Now the biggest optical telescope we have is in the 30 to 40 meter range. We would need something in like the 60, 80, 100 meter range. So if we can get the overwhelmingly large telescope built, which I
Right.
think will be 80 meters across,
Well, the original
or if we
design was
could get
100 meters.
Colossus.
Yeah.
Okay.
Yeah.
Yeah. And now there's Colossus, which I think is going to be 100 meters. Once those get built, which probably is going to be in 2040 or something, maybe, uh, then we would be able to detect the mountains on exoplanets.
I love that idea. We've talked about the overwhelmingly large telescope a couple of times in the past, and just this idea that originally the European Southern Observatory had considered the the 100-meter size telescope, and they were like, it was going to come in at like $1 billion, and they went, no, that's just too rich for our blood. And then you look at just the budget gobbling that's gone on with, say, James Webb, right? Man,
Right.
$1 billion just feels like a deal at this point. But so
Mm-hmm.
say you
Yeah,
could
that's a
see,
sale.
yeah, exactly, yeah. So say you could see mountains on an exoplanet. What would that tell you?
Um, A lot of different things, actually. So, mountains are tied very closely to the internal mechanisms of a planet, things like volcanism and plate tectonic movement. And if we see a lot of mountains, then that's an indication that this planet has those types of internal mechanisms. And we have no other way of knowing that right now. So, that'd be pretty cool. And then some other consequences are that how mountainous a planet is should be related to how dense the planet is, right? The denser a planet,
Mm,
the bigger its surface gravity. So the shorter mountains there should be. But if you see a planet that isn't as mountainous as you would expect, given its density and its surface gravity, then that's a sign that something is obscuring those mountains, and that something could be oceans. So we might be able to use mountains as a proxy for oceans.
like I know that, like, for example, when you're trying to do observations on an exoplanet, you've got these two methods. You've got the transit method, which allows you to make out essentially the radius of the planet, and you can work out its orbital parameters. But
Mhm.
um, you need to do the radial velocity method to actually figure out what the mass of the planet is by putting those two together. But I guess by seeing the height of the mountains, that could give you a guess at its mass, right? Because you would be able to sort of take a shot at its density. Like, mountains are going to reach their maximum height depending on the amount of gravity, and gravity will tell you the mass, and so on and so forth.
Exactly. Yeah. Unless there's something obscuring it, like
Like oceans, which
oceans
are
or
even
clouds.
more interesting. But
Exactly.
but then I guess I wonder if if you've got that overwhelmingly large telescope, maybe you are already able to see oceans on the surface of this exoplanet. Like, it almost feels like a lot of this could be you're
Yeah,
already getting some incredible observations with these enormous telescopes.
absolutely. Yeah. And other people are thinking of looking for oceans by looking at the glint that or the reflection of the star's light off of the ocean. So, I mean, people are getting really creative. We're just like scraping the bottom of the barrel when it comes to what we can eke out of a transit.
Yeah, I mean, it's like it really is a testament to just how clever the astronomers are already in what they're able to pull out of just so little data. Like, they can tell you the wind speeds, and they can tell you the some of the components that are in the atmosphere, and all of these you just can't believe it. It's incredible. All right, so let's
Absolutely.
move on to your other field of study then, in this idea of, I guess, what galactic habitability.
Yeah, that's what I call it.
So tell
Uh,
me more.
tell you more. Well, this is the question that I applied to grad school to answer. I wanted to know if there was a place in the galaxy where habitable planets are most likely to form. And the way I've approached that is mostly just by trying to find areas where I definitely don't think planets can form. And then I can check those off the list, and we don't have to waste time looking there. So I turned my attention to the center of the galaxy, this region that we call the galactic bulge, because unlike the disk of the galaxy that the sun is in, the galactic bulge is a lot more chaotic. Isn't technically the right term, but it's a lot messier. The orbits of stars aren't circular. They are moving a lot faster. They're intersecting with each other a lot more often. So I thought that maybe they would have more close flybys with each other. And I simulated the orbits of stars in this part of the galaxy to figure out how common those encounters would be. And they're really, really common. I learned that about 80% of stars in the Milky Way bulge have an encounter within 1,000 astronomical units every billion years, which is way more than I expected.
Yeah, and so what are the implications of that? If you are living on one of those, orbiting one of those stars, is that a bad day? Is that a a little bit of chaos that improves things? Sounds bad.
It's pretty bad. I mean, a lot of this depends on like the mass ratio of the two stars involved in the encounter, but encounters within 100 AU aren't that rare either. And so 100 AU encounter would totally mess you up. Like that could rip you away from your host star. It could destabilize your orbit so that eventually you get flung out of your system or you orbit into your star, which is bad, very bad.
Yeah.
But yeah, these encounters led us to believe that it's possible that we see a much higher rate of rogue planets in the bulge, planets that aren't orbiting any star.
And so I'm sort of like, I know that astronomers think that perhaps some of the catastrophic events that have happened long ago in the history of the Earth have happened from close encounters with other stars. But they're thinking about this in terms of like something that came by 50,000 astronomical units away, and that was enough to jiggle the comets in our Oort cloud and send them crashing in and causing destruction on Earth. And so when you think about things getting far closer, the kind of mayhem, and so where does this, I guess mathematically, as you sort of move away from the galactic bulge, where does this devastation settle down? How far away?
So if we're 8 kiloparsecs away from the galactic center, very safe in what I like to call the suburbs of the galaxy, all of this stuff is happening within 1.5 kiloparsecs of the galactic center. So it stops pretty close to the center of the galaxy.
Right. Like we are, I mean, what is it, 26,000 light years away from the center? Astronomers always thinking in kiloparsecs.
Right. My bad.
No, it's fine. It's fine. I just divide by 3. Anyway, multiply by 3. Anyway,
Yeah.
So like, but like under 10,000 light years, like close to the center, and then those close encounters happening all the time start to settle down to the point that planets have a shot at lasting a longer and longer period. So you've ruled out the galactic bulge, and not for the reason that I think a lot of people do, because I think a lot of people rule out that region of the galaxy because of the intense radiation from all of those stars.
Right. Yeah. Intense radiation and the high stellar number density means that there are more supernovae going off, which is connected to radiation, but slightly different.
Okay, so then where else would you rule out as a place for galactic habitability?
I would probably rule out the halo. So one thing that we know about, or that we think about habitability, is that you should have a lot of metals in your star if you're going to have planets that form these dense iron and nickel cores like Earth. And out in the halo, this like big cloud of dark matter, mostly, that exists around the galaxy, you don't have high amounts of metals in the stars because the stars out there just aren't old enough, or there haven't been enough generations of stars to seed the space with a lot of heavy metals. So I would rule that out for one.
But it feels like like a lot of the galaxy is still in play, most of it.
Most of it, yeah.
Right.
I guess
So,
that means I haven't done my job very well.
well, it just means that, it's a very difficult challenge. And also, I mean, we just keep finding that life finds a way. So, but I think I'm sure you want to resist the urge to be sort of thinking like that we just so happen to live in the best spot of the we're always so egocentric about our place in the universe, right? We just happen to live in the
Mhm.
best, and of course, that does work from one standpoint, which is that if this wasn't a good place to have life, then you wouldn't have life, right? Sort of an anthropic
Right.
principle take on it, but then at the same time, like, do you think that far closer to the center of the galaxy or much farther away from the center of the galaxy, it's still pretty habitable?
I'd say it's probably pretty habitable by something. Um, the thing is, when I talk about habitable zones, I don't mean that there are no habitable or Earth-like planets in the Milky Way bulge or in the halo. I mean that most planets that you find, or most planetary systems, probably don't have an Earth that could be inhabited by humans. I think it's much more likely to find an Earth-like planet or a planet that could host humans out here in the disk around where our sun is.
Right, right. Okay, okay. Um, and so is that sort of where your research ends, or do you think that there's a region that is more habitable, like super habitable?
Yeah, so I this isn't where my research has taken me, but I've done the literature searches, and most astronomers who do this type of galactic habitable zone work agree that the best place to find life is between 7 and 9 kiloparsecs away from the galactic center, and we are 8
8.
kiloparsecs away from the galactic center, and 8, yes,
Yeah.
we're right in the middle. And that's based on a number of different factors. That's looking at the radiation, the stellar number density, the metallicity, or how many heavy metals you have. They even start looking at time. If you take into account how many generations of stars have had the chance to live and die, it's looking like right where we are. As much as I hate to sound so narcissistic and anthrocentric, is the best place to be.
Right. There was a really interesting study that I saw that I think just came out today. I don't know if you saw it, but they were talking about the fact that spiral galaxies, I think something like 77% of the galaxies, of the big galaxies out there that we can see, are kind of like the Milky Way in this sort of spiral structure. And it turns out they're
Mm.
much better than some of the other kinds of galaxies, like the big elliptical galaxies or some of the dwarf irregular galaxies. So, have you started to extend that idea to you know, what kinds of galaxies are likely to have the largest galactic habitable zones?
I haven't, but now I want to.
Do you want me to send you the press release? I'll send you the paper um, at some
yeah,
point.
please do. I imagine that I think of habitability in terms of orbits and everything. And one difference that's very stark between spiral and elliptical galaxies is that spiral galaxies have very uh, orderly circular orbits for the most part out in their disks. And elliptical galaxies are just much more all over the place, where stars are whizzing around on weird rosette orbits and elliptical orbits. So that would be where my mind wants to go in thinking about the difference between the two.
Yeah, I haven't read the paper, but I'll send I'll send it to you afterwards. We did an article on it on Universe today. It just came
Well,
out from Whitmer, so Daniel Whitmer at University of Arkansas. So
cool.
it's a bunch of other ones, yeah. And I think they did it using the Sloan Digital Sky Survey. So yeah, it's kind of an interesting idea. But I think like what we're finding is that probably there's a lot more places, even just in the even in the solar system, that are habitable, but like Europa and Enceladus and maybe even Pluto and in the interior of Planet 9, whenever we find that. But it would suck. And the amount of free energy that's available to those life forms is fairly low. And even
Mhm.
there was a paper that I saw where they were talking about how much light falls on a planets that are orbiting an M dwarf, and it's a fraction of what you might need for, say, photosynthesis. So
Mhm.
we come back to probably wanting to look at that habitable zone around sun-like stars as the place to sort of find life flourishing, as opposed to life on the edge of survival. So
Yeah, although I think it's always a really fun exercise to imagine those super extreme conditions and think about the life that could thrive there. That's one of my favorite pastimes.
is is to imagine what kind. So if you did have to live in the permanently dark water environment of Europa, what kind of life form would exist? Yeah,
Exactly. Yeah.
there was a book. I don't know if I have it around somewhere. Somebody sent that I read, and they were talking about, like, if you were an intelligent life form living in one of these places, like if you were under the ice, and your whole concept, your worldview was this aquatic environment, and you didn't have space above you, but you had ice, and then you realized that you could drill into this ice, and so that would be your version of a moon landing, would just be to drill up through the ice. Or
Mm.
if you lived on an ocean planet, right, just to get to the surface where the pressure changes are so different that suddenly that would be you'd have to make a pressure vessel capable of allowing you to survive at the surface. And then to even perceive that there's a
Yeah.
universe would be a whole other level, right?
I mean, along the same vein, people, if you can imagine life forming on a tidally locked planet, on the day side of the tidally locked planet, they would have no idea that stars are there. They would have to
Right.
create some sort of suit or environment to get to the night side to be able to learn about astronomy and develop that as a science.
And it wouldn't even occur to them, yeah, to beyond their star. And they probably would develop, I mean, they would have some kind of a solar telescope, and maybe if there were other planets, like how we can see Venus in the daytime, maybe they would have some sense. But apart from that, it
Mm-hmm.
wouldn't even occur to them that there are other stars out there, until after a while they would start to recognize that maybe there's a distance to the sun, and then from there they would start to work it out, and would try to explore the bone chilling night side of their planet. Yeah, really fascinating idea. And so it's like each time you get one of these, you learn one of these planets, immediately you start to think of, like, what would life be like there? Is there
Yeah.
are there any other, like, ideas or places that have kept you fascinated?
Oh, so many. This is the basis for my show, Exo-lore. I mean, I in the past I've done planets that have high levels of carbon dioxide in their atmosphere. I've done planets around M dwarf stars, planets on eccentric orbits, like a very eccentric orbit that will take them far out into their planetary system over the course of their year. Just like I like the idea that life finds a way, and the physical characteristics of your planetary system will determine the culture that that life creates. So I like thinking about that.
I think this is a good sort of segue into this project that you're working on called Exo-lore. So can you explain this?
Yeah, so the word exo-lore is a portmanteau of two fields that I studied in college. Exo coming from exoplanets, so planets outside of our solar system, and lore coming from folklore. And I developed this idea to teach people how space can influence culture. And there are a lot of other lessons that go into it, but functionally, what I do is interview expert guests who come from all sorts of different backgrounds. So I've talked to psychologists and zooarchaeologists and linguists and art historians and fashion experts. And together we look at the physical environment on a planet, or like an imagined planet, and we think about what that would do to life and culture. So like what biology would thrive on this planet, and then what religion would they practice, or what would their clothes be like, or their architecture. And there are so many different parts to culture that we can't get to
Yeah.
everything in one show, but I try to tailor it to the expertise of the guests.
It's tough. I mean, when you're watching, I don't know. I'm sure since this is literally now your job, but I find like when I'm watching science fiction, and someone tries to introduce some really cool idea, like your brain goes, yeah, but what about this, and what about that, and what about this, and what would be the implications of that? It's like they mess with one variable, but then they don't consider the implications across everything. And like,
Mm-hmm.
I mean, so are there some examples that you think maybe do a good job of this?
I have recently stopped. Like I feel like I got to a certain point in my grad school program where I had learned enough that science fiction got really annoying. Like I just
Oh,
couldn't
it
take it
ruined it
anymore.
for you. Oh no.
Um, it did. And so I tend to focus on the things that are so obviously not accurate. Things like Rick and Morty, where like no one can watch that and think that it's a true depiction of how space works.
Of
But things
course.
like Gravity, for example, like I watched that and just like had a hard time keeping my mouth shut about all the things that were going wrong. So I don't have examples because I don't watch enough sci-fi. Although
Um,
I've heard The Expanse does a good job.
yeah, I love The Expanse. Yeah, and The Martian was great. I mean, like
Mm.
when people even try, that is like that's just going a long way. But I feel like you see sometimes them taking a crack at it. I don't know. Have you I don't know if you've seen the Orville, but this is uh, an attempt at recreating Star Trek, and they try to have these philosophical ideas. What if there was a culture where it was like this, and but then like immediately your imagination just thinks like, okay, great, but now I can imagine like why do they have Starbucks, right?
Mm.
And so you can imagine, well, obviously the reason they have Starbucks is because they have to shoot their TV show in downtown Los Angeles. That's why. Why does everybody have,
Yeah,
why do all the aliens speak English? Why, I mean, it's
that is one of my biggest pet peeves.
well, right, and because I think that I mean like we as science communicators have to deal with the I guess the collateral damage that science fiction does on our imaginations, because everybody wants to talk about wormholes, and everybody wants to talk about warp drives and transportation systems, and right, and and
Yeah.
and that's because they are plot devices to make it so you don't have to, that if your crew gets into their spaceship and then 17 generations later their descendants arrive at the destination planet and everybody has forgotten the purpose of this mission, that does not make a compelling story. I mean, it tells a different story, but it
Mm-hmm.
doesn't tell the one where your crew gets into their spaceship and flies to another planet this week. So, and yet we as
Yeah.
science commuters have to kind of go like, I know you came for the wormholes, but let's talk about exoplanets. They're cool.
Yeah. The thing is, you have to make the world familiar enough that people aren't spending time and energy trying to figure out how the world works and not paying enough attention to the story. So I understand that there's a delicate balance that the people in the writer's room have to strike between, all right, how do I make this story interesting, but also realistic, but make sure I'm not losing the audience along the way. So I feel for them, but I also feel like I've seen a lot of things where it could have been done better.
Part of it is like, this is not your problem. Although I believe I see on your website that you do offer creative consultation services to writers, uh, and so on, if they do want to reach out and get help with a fix.
I do, yeah. And I wish more people would take me up on it. But most of the people who have are, honestly, I get a lot of theater artists. and just like visual artists. I haven't gotten a lot of writers to take me up on that.
Yeah. But I mean, it's interesting. Like, if we've had some guests in the past. A lot of the people in this community do end up providing some consultation on it, and I think we're seeing science fiction take this a lot more seriously these days. I mean, you're exactly right that Rick and Morty is not an accurate depiction of space or aliens or interdimensional travel, but it does definitely pull a lot of really interesting modern scientific concepts that it's attempting to communicate. So, you sort of,
Yeah.
and even like Star Trek and The Expanse is another good example, right? Like a lot of these shows, they are taking the science more seriously.
Yeah, and that's really great to see. I would encourage the people watching this right now to pay attention the next time you're watching a piece of sci-fi or even fantasy, and try and pick out the elements that you think may have been put in by a consultant, either a science consultant or like a historian consultant, because if you start looking for it, you can see where it comes in.
Yeah, there was. Oh man, there's been so many. And unfortunately, sometimes like I know too much. So I know that Phil Plait did the science consultation on some show, and so I can see like that's Phil, that's Phil. Phil did that. I can see that, right? And then I could see like they they just threw out his idea. They ignored him there, and they ignored him there to their
Mm-hmm.
detriment. They should have listened to him because that is ridiculous. And so I think, is there a risk when you are coming up with a creative story if you do try to make it sciency, that then now you're in the danger zone because you're going to like you can't just go half sciencey.
Yeah, my biggest concern with going half sciencey is that people, if enough of it looks accurate, I think people might walk away thinking that all of it is accurate. And as a science communicator, that just really, it grinds my gears. I'll say that, because the last thing I want is people walking away from some experience with an inaccurate understanding of science.
Yeah. Well, I mean, for a lot of us, we were definitely inspired by science fiction. I definitely count myself as the Star Trek inspiration group, but you weren't, right?
Yeah, no, I have a very kind of circuitous way of getting to where I am right now. Um,
So,
I mean, unlike most, go ahead.
oh, I was going to say, yeah, no, please explain.
Well, unlike most of my colleagues, I didn't grow up thinking that the night sky was the most exciting thing from the age of 5. I didn't like or even get into astronomy until I was a sophomore in college. And it was a total fluke that I found it. One of my friends dragged me to an introductory astronomy course, and I signed up for it because the professor said we'd get free pizza every week. Like that's why I'm an astronomer today, is because of free carbs. Uh, so that's a lesson for you. But when it came to science communication, I had no idea that was a thing until I did my first research internship at the National Radio Astronomy Observatory in 2014. And while I was there, I just like went down the wrong hallway one day and I found the education and public outreach offices. And I wandered in and I was like, hey, this looks cool. What are you doing? And they explained it to me. And I, ever since then, have just thought that science communication was one of the coolest things I could possibly do with my time.
Yeah, I mean, that whole journey about people showing up, like saying, like, let's talk about wormholes. I want to talk about black holes. Like, I think for a lot of people they find that very exhausting, and for me I feel like that's the introduction to modern space and astronomy is like, yeah, we can talk about black holes, um, but
Mm-hmm.
let's talk about supermassive black holes, and let's talk about the search for stellar mass black holes, and let's talk about the first pictures of of a black hole taken by the Event Horizon Telescope that was done using interferometry. And let's talk about interferometry. So it's sort of the way into very fascinating conversations. And I think that I find that process actually fine, and I enjoy it. And I know that a lot of people kind of get grumpy about having to talk about wormholes again, but I think it's fine. I think it's great. And I think that over time, the audience just matures and just gets to this point where they are hungry for the latest insights in exoplanets or black holes or extreme astrophysics or space exploration or whatever, and they're up to speed. And it is just this journey that people go through. And science fiction sort of dumps them off at the door, unceremoniously with messed up expectations. And it's our job to kind of, guide them in, offer them carbs, and, and carry on the education.
Yeah, I totally agree with you. Although for me, it's usually aliens as an introduction and not wormholes.
Either I get aliens too. It just as absolutely. People want to know what I think about those UFO videos and where are all the aliens, and that there's no conversation that I would like to have more than where are all the aliens. People won't like my answer, but I would love to have that conversation. So I've got a couple of questions I would love to throw at you. This one comes from Arjone. What would be the weirdest way of keeping time, considering that things can happen like tidal locking? How would an alien civilization who is locked to their sun think about time?
Oh, Arjone, I love that you asked this. So there are a few different ways. You could measure it by crop cycles. So if you are on a tidally locked planet and you are facing the sun, or the star, you probably have some type of plants and they probably grow in a cyclical manner. So you can trace time using that. You could do it with biological cycles, assuming that they have some type of circadian rhythm just based on a body's natural needs. They might measure it that way. On the night side of the planet, if life forms there, I can imagine that maybe they can trace some time by the motion of the stars, but maybe longer time cycles might be done by comets passing regularly, like Halley's Comet or Halley's Comet does here.
Yeah.
Yeah, that's how I imagine.
Yeah, I mean, I think that if you were on the night side or if you were like right at the Terminator, then you would maybe get a chance to see the stars and you would get a sense that their position changes as your planet goes around, and chances are if you're tidally locked, you're going around very quickly. And if there are other planets, and maybe they could be seen in the daytime, but it is sort of like, say none of that is, you're dead in the middle of the planet, you're facing the star. Time has no meaning. Like, there's no day, there's no night, there's no month, there's no year. It's
just like living in coronavirus.
yeah, exactly. Yeah, right. That's exactly it. We're feeling it right now. But it's this, like, what does that do to your culture if there is no concept of, we take these divisions that have been provided by nature and we start slicing and dicing them and comparing them and contrasting them and agreeing on them. But if those didn't exist, it is such a fascinating idea to think about, and yet a culture would exist.
A culture would exist, and it could be a culture that doesn't really care about time, and as long as you get what you need to do done, then like, who cares how long it took you to do it?
Yeah, and I can definitely see that. Yeah, you might measure it in terms of how long does it take a child to grow to adulthood, and then you would use that as a basis of some sort of a time, and you would have, or like, I mean, as you said, crop circles. There would be some kind of life thing, but the seasons wouldn't really change. It's a fascinating idea. I love it.
Yeah.
Steve Sharmer asks, if you got some telescope time on Hubble or James Webb, what would you target?
Ooh. I have never actually worked with a telescope where I try to point it at something. I've only ever worked with archival data. So if I got some time on a telescope like Hubble or James Webb, I would want to point it toward, I don't know. I want to point it towards the center of the galaxy and trace the motion more accurately, trace the motion of a star closer to the bulge or a few stars closer to the bulge, to see if my simulations are reliable, or as reliable as I think that they should be. So if I'm tracing the motion of stars using observations, then I can just numerically count how many encounters these stars have.
Right, right. And I guess you would probably want some kind of infrared instrument to be able to see through that gas and dust.
Mm-hmm. Yeah, I probably couldn't do it with Hubble or James Webb. I'm imagining a world where the Gaia team says, "All right, astronomers, you can request observations now." That's what I would do with Gaia.
With Gaia,
Yeah.
does it have
Um,
the sort of the capability to do that?
yeah. So Gaia already has observed some stars that are technically in the bulge, but they were on the outer edges. And so it can look through the dust. I don't remember exactly what its bandpass is, but it can definitely see to the Milky Way bulge.
Wow. Okay. And I mean, I sort of don't imagine Gaia as a telescope that you would use to look at any individual star. I sort of imagine it as it's looking everywhere all the time, and then building up a gigantic survey of this information. But you could force it to just
Yeah,
watch
that's what it's.
some star.
Yeah, you could. Yeah, it was definitely built as a survey, a series of survey instruments.
Right.
But if I could take control of it, then I
Comment.
would try to follow a few single stars so that I
Right.
could track their motion really, really precisely.
Yeah. I mean, and if you were close enough to the very center of the galaxy, you could probably overlap with observations of stars going around, say, the supermassive black hole. Like I'm sure there's some other astronomers
Yeah,
could
if it
jump in
can
as
see that
well.
far.
Yeah, yeah, okay. Um, Johnny Z is asking how many exoplanets are in 100 light year radius of us. So how many do they figure there are around us?
Oh, I will say that I don't actually have a number off the top of my head. But there around the sun, there's about one star per cubic parsec, and 100 light years would be 30 parsecs. So, trying to do some quick mental math,
I get 100.
there would
I
be,
get 500
yeah,
stars within 100 light years.
yeah.
Is one number.
Thanks for doing that, because my mental math was going to be much slower than
Yeah,
than your typing.
yeah, but right, yeah, but I think that number is. I mean, I've seen a couple of estimates, but that's a rough estimate. Is you got about 500
Mhm.
stars within 100 light years.
Yeah, and
Um,
the estimate, like the average number is that there are two planets per
oh, I
star.
got. I'm
So that
sorry.
means that there should be about 1,000 planets. Go ahead.
Oh, yeah. So sorry. And that's like direct observation. So we know of that many stars that are within that range, but there's actually, if you actually do an estimate and you include the red dwarfs, the estimates, then there's probably more like 10,000 within that
Ooh,
range. But the vast majority of them are going to be red dwarfs. So
that makes sense.
yeah, yeah. I guess I need to do a video on this and get an answer. Someone's posting
Yeah,
4,500
and I'll watch
in the
it and
chat.
then remember the answer.
Okay, perfect. Yeah, I'll talk to someone from Gaia, ask them how many stars there are, do a video, give it to you. Also ask them if I can have a friend use your telescope, for just a couple of days. Nico Girl asks, would globular clusters have the same orbital difficulty as the galactic bulge? So same problem there in clusters?
Yeah, that's a really great question. Some work has been done on this in clusters, and globular clusters are a little bit less dense than the Milky Way bulge, but not much. So they could have this problem. The issue is that they aren't as big, and so there just aren't as many stars to have these types of encounters. But yeah, the same problem does exist on a smaller scale.
Right, right. Um, yeah, I guess whenever you have stars in close proximity with each other, then you're going to have mayhem, orbital mayhem.
Absolutely.
Yeah.
Yeah. All of
Uh,
those stars packed into a small space, they want to touch each other. And that means bad things for planets.
yeah, yeah. Sometimes, sometimes they collide in these clusters. People are giving me a hard time about the way I pronounce globular because I've clearly been because I used to say globular because I didn't know any other way to pronounce it. It was just the way I read it, and people give me a hard time, and then so I sort of started to get in line and conform with what everyone wanted me to do.
Mm-hmm.
But then it turns out that globular is a perfectly accurate way to say it as well. So you could say globular or globular.
Huh.
And unfortunately now my brain is ruined and it's too late for me. So save yourselves,
Oh,
everyone. I know.
that's so sad. But at least it means that these people who are making fun of you have been with you for a while
That's
because they
exactly
remember you
they
saying
make
it the old way.
that's right. So they now make fun of me for conforming, which is like it's like double mean. Um,
Oh.
Sebastian Garapay asks, have we discovered any rogue planets?
Yeah, but very few. I would be shocked if the number were higher than five. A lot of them have been found using methods like microlensing, and
Right.
for that we just have to be really lucky. We just have to get lucky enough that this planet passes behind some microlensing source that we can actually observe.
Right. And so you get this momentary time where a star dims, you know that there was a planet there, a rogue planet, and you never get to see it again. Um, I
Yeah, yeah. So they're really hard to confirm too.
um, there was a again, I think that book that I was talking about life forms living on these worlds. They also considered what it would be like to live on a rogue planet because in theory these planets could still have internal heating. They could have liquid water under them, and yet same things get weird
Mhm.
again, right? Because you make it to the surface and you don't see a star. You just see all the stars out there.
Yeah, unless you're in some dusty region, and then it's just darkness, assuming that they don't see in the infrared. If they evolved around an M dwarf star, for example, they might have evolved to see in the infrared range.
Another idea is just this idea that in the far future, the universe will be a lot less visible than it is today. The galaxies will be receding far away from us. The bright, hot stars will have died out. And so
Mm-hmm.
imagine one of those, those future civilizations finally, living around a red dwarf star. They live on an icy world. They finally dig their way to the surface and they look around and they just see their star and then they don't see anything else. Cuz
Sounds so lonely.
yeah, well that's the thing that we do live in this very special time in the universe that we happen to live within the first five, first 15 billion years of the age of the universe.
Mm-hmm.
And that's kind of an incredible idea about what that this is just a fraction. If the universe will be around for infinity, that we are here for
Mm-hmm.
the first 14 billion years of infinity is really lucky. But then back to that idea of that galactic habitability, right? Um,
Right.
uh,
I've never thought about it quite like that. That's so nice. We're so lucky.
well, we missed
I
the
feel like every
real
time I
party.
learn something new,
Yeah, yeah, we missed the real
oh,
party though,
yeah,
which was like 3 billion years after the Big Bang. Um,
true.
Steve
True.
Sharmer asks, what is Moiya's guess? First alien life found on a planet or moon?
Moon. My
Moon?
first guess is moon, and I'll be completely transparent and say that that's probably because my advisor is David Kipping, who has been
Yes.
searching for exomoons for like 20 years, and I might get my funding revoked if I didn't say moon.
Right. So not only moon, but specifically exomoon, thanks to the hard work with David Kipping and the rest of the people at the Cool Worlds Lab.
Yes.
Yeah.
Yes,
Yeah.
exactly that. No, but I do think that we're probably closer to definitively finding an exomoon than we are to definitively finding Earth or life outside of Earth.
Yes. Yeah. I mean, I think we are just a decade away from finding an exomoon, and we could be never away from finding life on another planet.
Mm-hmm.
Arjone asks another one. Do you think civilizations in the Trappist system would be spacefaring because the other planets are so close?
Yeah, when I actually have done this as an exercise, and having close planetary neighbors will give you it'll make it easier, I think, or like you'll be more motivated to try and get to those nearby planets, and it'll be easier because they're so close, and there'll just more times when your orbits will line up, so you can be close together to have those little planet hops, and from there it'll be easier to get even further outside your planetary system. So yeah, Arjun, you should be on my Exo-lore show. You should make some planets for yourself and imagine the cultures there.
Arjone asks the best questions. Every episode. Absolute pleasure to have Arjone watching the show with us. But I love that idea that, like, for us, having the moon there was an absolute fortunate situation, and all it took was an enormous research project and risk taken by a bunch of people to land on a frozen hellscape desert place and then come back. Imagine if you've got these other planets that are getting even closer than what the Earth is, say, in the moon, or roughly the same kind of distance, and those other planets are in the habitable zone, and you're making observations of these other planets, and maybe that they have liquid water on them, and maybe you can tell what they've got in their atmospheres, and maybe you're sending probes. Like, it would be really hard to resist having
and going even further than that, since so many of the planets are in the habitable zone, it's more likely that life arose on the different planets, so they could collaborate. And before they kind of cross-pollinated, they would have reached their own conclusions about space travel, and they would have developed their own methods. And if they work together, then it just like the rate at which they can advance is just exponential. So I think that they would be very successful space travelers.
right, or go to war. But but
That too.
yeah, but I mean, that
I'm
idea.
trying to be optimistic here, Fraser.
Yeah, no, absolutely. Yeah, they would just be inspire each other into acts of brave exploration, and it would be wonderful. What could go wrong? um, let's see. So what are you working on? So if people want to find out about some of the projects you're working on, where should they go?
Yeah, so you can follow me on Twitter. My handle's GoAstromo, and I tweet about all of my projects there. So you'll be notified if you follow me when new Exo-lore episodes go up. But you could also just subscribe to the Exo-lore podcast. I think it's available pretty much everywhere. I'm still waiting for Apple Podcasts to accept my attempt to distribute to them.
When
Yeah,
did you
that's where you can find more about me.
start this up? Because I'm having a hard time finding it.
It's pretty new. So I was doing Exo-lore as a live show in New York City,
Yeah.
but then I decided to put it on YouTube and make it a podcast after coronavirus started, and I put up a new episode every 2 weeks. So if you search Moiya McTier Exo-lore
Yeah.
podcast, you should find it.
Yeah, I found the
Yeah.
one on Anchor. Are you recording it through Anchor?
Yeah.
Okay. Okay.
I'm hosting it on Anchor. Yeah.
Okay. All right. And then and then in theory, Anchor should feed it off to iTunes
Yeah.
and okay. All right. Okay. Yeah, and then of course you are a regular contributor on the Weekly Space Hangout, and some people can always hang out and watch you reporting news there. But it's great. I really enjoy that cross section of being able to bring this idea of looking at these kinds of ideas and stories and cultures and all of that, but coming at it from that scientific point of view, which I think is, it's nice to see those two sides come together at the same time in one human being. It's,
Thank you.
yeah, it works really well. I've
Yeah.
definitely, and I will definitely check this out and try and help you get the word out. So thank you for
you.
taking the time to chat with me today, and thanks for pushing your satellite bandwidth to the absolute max. Apologies
My
to
pleasure.
everybody.
Absolutely.
Well, Moiya, thank you.
I'm sorry. I promise I'm not actually this blurry in person.
yeah, herky jerky, and with a robot voice. So thank you everyone for watching us today. Thanks to all of the moderators for tackling all of the issues that came up. Thanks to everyone over on Twitch as well. We know you're there. We saw some of your questions pop up. Again, if you want to, you can see more. Just go to Moiya McTier. We'll put a link in the show notes. I will, and also we'll put a link to, I think because you have a YouTube channel, I'll be able to directly link to it. And at some point in the upcoming weeks, you will be joining us back again on the Weekly Space Hangout, and we will chat about whatever space news is coming up. So,
Yeah, we will.
right on. Okay, well, stay safe and stay in your cabin and try not to go crazy. And let's hope that the coronavirus settles down so that we can all go back to work and you can actually turn this into a real live thing again.
Yeah. Yeah. Thank you. Take care, Fraser.
All right. Thanks, everybody. We'll see you next week.
Bye.